Hello, this video is going to explain polar coordinates in a simple, easy to understand kind of way. Let's say we have to get from this green dot to, which green means go, to the pink for stop. I couldn't find red, so I did pink. There are two ways to get there. We can go the traditional way of rectangular coordinates over 3 and up 4. So let's call this the point then 3, 4. That's the rectangular coordinate point 3, 4. Let's be a car now. Hey, it's Cactus Lightning McQueen. See the cactus on there? So Cactus Lightning McQueen starts here at the beginning, and he goes over 3, makes a left-hand turn, and then travels 4. So 3, 4. That's a distance of 7. 3 and 4 makes 7. Lightning McQueen has to travel on the roads. But what if Lightning McQueen wasn't a Lightning McQueen and he was this helicopter? Well, a helicopter doesn't have to travel on the roads. The helicopter can turn an angle and then fly a straight distance and do the same thing. So turn an angle, fly a distance. Now the problem with polar coordinates is the fact that it's r theta instead of theta and then r. But I think about it as turning an angle and then traveling a distance. And r represents like a circle. So this would be like a complete radius of a circle here. So we're finding points on a circle, basically. And you can find points on the circle, you know, going over 3 and up 4, or turning an angle. And I'll put the angle in here as theta. So turn an angle and then go a distance. So I know that my distance is 5 because this is a straight up 3, 4, 5 triangle. So I know that this is equivalent to 5 comma some angle. But what angle is it? Using trigonometry, we can use inverse trig functions. You use any one you want to. I'm just thinking slope here because I have the 3, 4. So I'm going to do inverse tangent of 4, 3. Be opposite over adjacent. Type that into the calculator. So inverse tangent of 4/3 is equal to that in radians. That's not degrees, that's radians. I will multiply by 180 over pi, and that'll convert it to degrees. Or I could put the mode on the calculator into degrees. It's 53.13 and change. I will write in here that that is equal to 53.13 degrees and change. Or you could say this theta is this exact answer right there, the inverse tangent of that. Let's see that it actually is 53 degrees, turning the helicopter 53 degrees and change, and then flying at a distance of 5, versus driving the car 3 and then turning and going 4. It should be the same. I have a protractor here, lining up the protractor perfectly. There's the target, there's 10 up to 50, and you can see that it's right at 53 degrees. This isn't a perfect drawing, but it's right there at 53 degrees. So this works out. The connection between polar coordinates and rectangular coordinates is turning an angle and going a distance.